in secondary school. Now I'm going to ask you, have you ever wondered how many colors it takes to fill in a map? If you have, look no further because Chae Hwan will be teaching us about the four-color map theorem and how it has been proven. So whenever you're ready, please take it away, Chae Hwan. We're all listening.
Hello. Can you hear me?
Yep, Shiwan, we can see your screen clearly and we can hear you as well.
Okay. So I will start. Hello, my name is Chae Hwan. I'm in grade 10 from Western Secondary School. Today, I'm going to briefly talk about four-color theorem. First, what is four-color theorem? The four-color theorem is the question whether any flatland map can be colored only using four color in a way that doesn't share the same color between adjacent area. The picture on the slide, you can see, this is the map of Canada, color only using four color. It's one of the example of four color method. Okay, going to the next slide. History of four color method. The history of four-color map theorem began in 1952 when the English mathematician Francis Guthrie he was coloring a British map for each reason. When he realized that if there are only four colors, adjacent area could be painted without overlapping each other. He wondered if he could fill all the regions just using four colors. He asked his brother Frederick, who was the student of Rogers Morgan. Frederick asked Morgan about map and the four color that he heard from his brother. Many other mathematicians, including Morgan, tried to solve the four-color problem. This problem was so simple that even children can understand the question. So many people, including mathematicians and Morgan, tried to prove it, but failed. Many people said they solved the four-column problem, but most of them were wrong, and even mathematicians stayed on the partial or indirect proof for a while. 27 years later, in 1879, when Alfred Kemp proved about four-column theorem, it seems that this problem was solved. However, 11 years later, 1890, the error has found it in its proof, so it came back to original point. On to the next slide, second part of the history. About 70 years later, in 1960, German mathematician Heinrich Fisch developed a method to prove the four-column problem using a computer. He classified all maps into finite number of types, but he gave up when the number of map cases are over 9,000. And the computer that he tried to prove, he, the computer that he tried to use in 1960 takes more than 10 years to calculate all the cases. About decades later, in 1979, chemists Ethel and Wolfgang Haeckel in the University of Illinois succeeded in proving the problem after running two computers for 1,000 hours, based on Hitch's idea in 1960. This was the computer in 1970 when the four-column theorem was proven. You can see it is very big compared to now, and it was very slow. When verification, Appel and Hacken used the computer to organize the map model into every possible cases, then try to see if the four colors are applied there. If there are no counterexamples, then the then the then the problem is proven. Even if counterexamples are not found, it shows that this problem was proven. So it was very simple method to solve this problem. As you can see on the slide, this is an example of map I just pulled from internet. They changed to all this model into right side to make calculation much more easier. When Fish first organized the map model, there was 9,000 map model. 9,000 map models were there. When Appel and Hacken simplified the map model, it reduced them into 1936. Hacken and Appel applied 487 discriminant filters out of 1936 model, calculated two computers and verified each other. They did all the proof one by one, so there was lots of result of this model. You can see on the both slide. This is one of the map models that they proven that it can be worked by four color. But this method was unconventional compared to 1970s. That this problem has proved by computers. So this proof has been generalized by many mathematicians at the time that there was no simple formula or answers. In addition, this was the first proof. This was the first proof that using the computer in history of mathematics. Coloring the real map. As shown as earlier, this problem starts with question whether it is possible to paint the map for four colors. So the proof of four-color theorem itself are not useful. The four-color theorem is just a theoretical statement that it can be possible to paint all the regions with four colors. But in the map you can see on the both sides, there are no reason to color only. There are no reason to color maps only using four colors. So most of not use lots of other colors because of seas, lake, or border. But still, it helps on planar graph, improving planar graph area and computerizing the proof. In conclusion, it was a very interesting question that it takes 150 years to prove this question and make many people curious about it. I think this is all my presentation. Thank you.